Alright, so in this video for part 4b, chapter 15c, we're looking at continuous random variables now. In the last video, we combined and we subtracted and added discrete random variables. Now we're looking at continuous random variables. And there's a couple of things that we kind of have to keep in the back of our minds when we think about continuous random variables. The first one is our normal model. And if you guys recall that from part 1, we're going to do a lot with our normal stuff again, NCDFs. Alright, normal model is a continuous random variable. Okay, so normal model, the reason why we like normal models is they are a continuous random variable. Everything's a little bit easier to use when it's a normal model. Okay, now the good news is that everything we've done so far with discrete random variables is that with continuous random variables, they follow the same rules. Okay, so everything we did in the last video is going to be true here also. Okay, they all follow the same rules. Alright, and then when you have two independent continuous random variables that have normal models, this is really key, so does their sum and difference. Okay, we're going to use that a lot today. Okay, if our events are independent and they're continuous random variables, so are their sums and their differences. Alright, now that we're dealing with continuous variables, okay, now there's a few different steps that we're going to deal with when we find the probability of continuous variables. Okay, first one is we just want to write down what we're looking for. Okay, that makes it easier to see what you actually need. So write down what you are looking for. Okay, so we write down, so we're going to be looking, this is our probability chapters. Okay, so we're going to find a lot of probabilities, so we're going to be looking for the probability of something. We want to make sure we write that down. After we write it down, if necessary, we're going to rewrite all variables on one side. Alright, and we'll do a couple examples. You guys will see what I'm talking about. Okay, we're going to be looking at a couple of different examples where we're looking to see if one thing is bigger than the other one. So we're going to rewrite all the variables on the same side. Okay. Now our third step is that we need to find the mean and the standard deviation. And that's along with what we did in the last video. We just need to find the expected value of something and the standard deviation. Alright, so find the mean and standard deviation. And lastly, what we're going back to part 1 here, is we need to find our z-score. Yeah, that beautiful thing, that z-score. And then what do we use to find our percentages after we have the z-scores? We're going to use our calculator function, our NCDF. Alright, so now we're going to want to go to example 1. Okay, in example 1, a company manufactures and ships home theater systems. At the end of the production line, the systems are packaged and prepared for shipping. Stage 1 of this process is called the packing, and that can be described by a normal model with a mean of 9 minutes and a standard deviation of 1.5 minutes. Okay, so that's some key information there, so we're going to go ahead and write that down. So our packing follows a normal model, and that's with a mean of 9 minutes and a standard deviation of 1.5 minutes. Okay. Stage 2 is called boxing, and that can be also described by a normal model. Okay, so we got boxing, and that has a mean, so normal model with a mean of 6 minutes and a standard deviation of 1 minute. Now we want to find what is the probability that packing 2 consecutive systems takes over 20 minutes. Okay, so we're just going to be dealing with just packing right now. It's asking us 2 consecutive packing systems. So for part A, we're looking at what is the probability, okay, that our first package plus our second package, and we want to know it's over 20 minutes, is greater than 20 minutes. Okay, all our variables on one side, so we don't have to worry about that step now. All right, so now we need to go through, we wrote down what we needed. Now we need to find what is our mean and what is our standard deviation. Okay, well, we just need to find the expected value of these 2 continuous random variables. So we have our expected value of our packing 1 plus packing 2, which that's just, we just add our means together, so 9 plus 9. So our expected value for packing 2 consecutive boxes is 18 minutes. Our average is going to be 18 minutes. And then our standard deviation of packing 1 and packing 2 is going to be equal to the square root of 1.5 for our first package squared plus 1.5 of our second package squared. And if we calculate that out, we get 2 minutes and 12 seconds. So for our 2 consecutive systems, packing systems, we can say that that is going to be a normal model with 18, a mean of 18, and a standard deviation of 2 minutes and 12 seconds. Okay, so now that we've found our mean and standard deviation, now we can go ahead and find our z-score. Now, just in case you guys forgot, okay, our z-score, if you remember, is our x value minus our mean divided by our standard deviation. Okay, so in this case, our x value that we're looking for is 20. Okay, so it's going to be 20 minus our mean, and we found that our mean was 18, divided by our standard deviation, 2 minutes and 12 seconds. And if we calculate that out, we get that it's 0.94. Okay, so now we found our z-score. Now we can use our NCDF to find our actual probability. So remember, anytime you put something into the calculator, please make sure that you write down what you're putting in. So we're going to use NCDF. We're going to go ahead and use our z-score. So 0.94 is going to be our lower. Our upper is infinity. And then we have our mean. So remember, whenever we use normal model, when we find our z-score and we use that normal, we're just going to use, has a mean of 1, or 0, I'm sorry, and a standard deviation of 1. And if you guys use your NCDF, and if you need to, go ahead and pause it and practice it. Okay, we need to kind of get into the use of that. We do got midterms in, 2 weeks now. Okay, if you calculate that out, 0.174. So the probability that our packing 2 consecutive systems takes over 20 minutes is going to be 0.174 or 17.4%. All right, now for B. Okay, B is asking us what percent of the theater systems take longer to pack than to box. Okay, so if we write down what it's looking for, we want to know what's the probability that our packing is greater than our boxing, is what we're looking for. Now remember, we want to get both of our continuous random variables on the same side. So then I'm going to just subtract B from both sides. So I'm going to get the probability that my packing minus my boxing is greater than 0. Okay, and that's, now we have it on one side. That's going to make it easier. Now we know how to find our mean and standard deviation. So our mean, you guys should know how to do this now. Our expected value, we can just go packing minus our boxing. We're just going to subtract our 2 means. So remember, our boxing of packing is 9, and our mean of packing is 9. Our mean of boxing was 6, so we're going to subtract them. So our expected value of packing minus boxing is going to be 3. And now for our standard deviation, again, of packing minus our boxing, that's going to be equal to the square root of, okay, our standard deviation of boxing, or packing, which is 1.5 squared. And remember, it does not matter if we add or subtract the random variables. We always add them for our standard deviation. So plus 1 squared. And that's going to give us 1.803. Okay, so our mean for packing minus boxing is 3, and that has a standard deviation of 1.803. So now remember, with continuous random variables, if they both follow the normal model, which packing and boxing said that they did, then their sum or their difference also follows the normal model, which is what we have here. So then we can use our z-score to try and figure out our probability. So then we're going to find our z-score. Okay, the x value that we're looking for here is 0. Okay, so that's our x value. So it's going to be 0 minus our mean that we found, which was 3, divided by our standard deviation, 1.803. And if you calculate that out, we get a z-score of negative 1.664. Okay, now we can put that into the calculator. We should know how to do that again. So in CDF, make sure you always write down everything you put into the calculator. So we have in CDF, my lower is going to be negative 1.664. My upper is infinity. Standard deviation or median of 1, standard deviation or 0, standard deviation of 1. If I calculate it out, I have a 0.95. So I've got a 95% chance that the theater systems take longer to pack than they do to box. Alright, let's go ahead and do example 2 now. So at a certain coffee shop, all the customers buy a cup of coffee. Some also buy a donut. The shop owner believes that a number of cups he sells each day is normally distributed with a mean of 320 cups and a standard deviation of 20. Okay, so that's our first one. We're going to go cups as normal model with a mean of 320 and a standard deviation of 20. Okay, he also believes the number of donuts he sells each day is independent of the coffee. All right, and that is also normally distributed. So our donuts is normally distributed with a mean of 150 donuts and a standard deviation of 12. Okay. Now the shop is open every day but Sunday. Assuming his day-to-day sales are independent, what's the probability he'll sell over 2,000 cups of coffee in a week? Okay, so you got to think, all right, he's open every day but Sunday. So how many days is he going to be open then? 7 days in a week. We're taking away 1, so he's going to be open for 6 days. All right, and for each day, we have the normal model of the cups and of coffee and the donuts that he sells. So then we're going to go ahead and we want to find what's the probability. And we're looking, the first question is he'll sell over 2,000 cups. So we're only going to look at the cups of coffee right now. Okay, so we want to know the probability of cup 1, which is just day 1, so that'd be our Monday, plus cup 2, which would be our Tuesday, plus ... And again, we have 6 days because we took away Sunday, so cup 6. So we're looking at that probability. All right, cup 1 plus cup 2 plus cup 3 plus cup 4, cup 5 plus 6. As we want to know, is that going to be greater than 2,000 cups? That's what we're trying to figure out here. Okay, so we wrote down what we needed. Now we need to find our mean and our standard deviation. Okay, these are very similar to examples from yesterday now when we did our discrete random variables. So our mean, our expected value, and we're looking at C1 plus all the way down to cup 6, to our 6th day. That's going to be equal to 6 times the mean of cups, which is 320. If we calculate that out, we get 1920. All right, so I want you guys to go ahead and pause it. Find me the standard deviation of that. All right, check your answer with mine. So you should have gotten a standard deviation of 48.99 cups. So now our next step, we found our mean, we found our standard deviation. Now we need to find our z-score. So the x value that we're looking for here, again, is our 2,000. Okay, so we're going to go 2,000 minus the mean that we found, which was 1920, and we're going to divide it by our standard deviation, which gives us a z-score of 1.633. Okay, not a bad z-score. So now we're going to do our NCDF. Okay, NCDF of 1.633. Again, that's going to be my lower because I'm looking for greater than 2,000. My upper is infinity. Mean of 0. Standard deviation of 1. And if you go ahead and calculate that out, you will get a probability of 0.5. So we got about a 5% chance that he'll sell over 2,000 cups of coffee in a week. Okay, so now let's go to part B. Okay, part B is a little bit different. All right, so now we're looking, if he makes a profit of 50 cents on each cup of coffee and 40 cents on each donut, can he reasonably expect to have a day's profit over $300? Okay, so we're going to look at, write down what we want. We want the probability, and again, this is part B, sorry. So we want the probability, let me do that. Okay, so we want the probability that he makes 50 cents on his coffee, so then we're going to go 0.5 times his coffee, and we want to know if that added to, he makes 40 cents on each donut. So again, 0.4 to each donut. And we want to know, can he reasonably expect to have a day's profit over $300? So we're going to go greater than 300. That's our probability that we're looking for. Now notice, we're not just adding the continuous variables, random variables. We are also multiplying them by a scalar. Okay, we still need to go through. We need to find what's our mean of that going to be. Well, our expected value or our mean. Okay, 0.5 times our cups plus 0.4 times our donuts. Well, that's going to be equal to, so we multiply our scalar times 320, and then our scalar of 0.4 for our donuts times 150, and that's going to give us a mean of $220. So now we need to find our standard deviation. Now our standard deviation, okay, and it's going to be the same thing that we're looking for, 0.5 times our cups plus 0.4 times our donuts, and we're adding those together. So now remember, whenever we multiply by a scalar inside of our square root, okay, we need to also square that, because we're multiplying each cup and each donut he sells by his profit that he'll make. So he'll make 50 cents of profit. So we're multiplying that to every cup. So because of that, we need to make sure that we square that 0.5, and then we also square, that's going to be multiplied times our standard deviation of our cups, which is 20. And that's going to, then we're going to add that to, again, our scalar for donuts, which is 40 cents, so 0.4 squared times 12 squared, which is 12 is our standard deviation of donuts. Okay, and if you guys go ahead and you calculate that out, you should get a standard deviation of 11.09. Okay, so again, the big difference is that when we multiply by a scalar, so each one of those scalars, that we need to make sure that we square those scalars when we're trying to find our standard deviation of those two random variables. Okay, and that's a big difference there. We need to make sure that we know that one. So now we have our mean, we have our standard deviation. Now you guys should be able to go ahead and find your z-score. Okay, so our z-score is equal to, again, our x value. We're looking, is it greater than 300? So our x value is 300 minus our mean of 220 divided by our standard deviation, which gives us a z-score of 7.21. Okay, now you should be telling yourself that that's a huge z-score. Okay, that's a huge z-score. So you should be able to kind of know right away that I don't think that's going to happen. All right, but we're still going to calculate that. So go ahead and put that into your calculator in CDF. My lower is 7.21. Okay, my upper, again, is infinity, because we're looking at greater than 300. With the mean of 0, standard deviation of 1. And if you calculate that out, you get something that goes all the way out. It's like 0.0000000. All right, it should say e to the 13th power, e to 13. Okay, so we're going to say that that's approximately 0. Okay, so he basically does not have a chance to profit over $300 in one day. All right, now for example 3 and actually example 4, I'm going to have you guys go ahead and do those by yourselves. So you can go ahead and pause the video and then check your answers with me. It's really close to the same ones that we've done. So go ahead and pause your video now. All right, check your work with mine. So we were looking for the average of Wendy plus Jill plus Carmen plus Latrice. Each one of those is a random variable, each person. So we're just going to add all the averages together. And then for Wendy, Jill, Carmen, and Latrice, we're going to find the standard deviation. So you should have gotten a mean of 224.2 seconds and a standard deviation of 5.558. All right. Now for B, we wanted to know what is the probability that they're less than 210 seconds. And do you think the team is likely enough to make the time at the section meet? So we're looking for the probability of all of our random variables added together being less than 210. Okay, this is our first less than example. So you should have been able, you have the mean standard deviation, you should have been able to find the z-score at negative 2.55. Okay, and now since it's less than, okay, so now we're looking at NCDF negative infinity to our z-score of negative 2.55, 1, which gives us a probability of about 0.5%. All right, and now that since we're doing less than, I also drew you the shaded area that we need to get for our on the normal model, so you can see that we needed to go from negative infinity and up. Okay, so I want you guys now go ahead and pause it again. All right, and we're going to do example. I want you to do example 4 on your own, and then check your work with mine. So go ahead and pause it now. All right, so for our last example, example 4 here. Okay, so we wanted at first we wanted the probability that the dog's cost was going to be greater than the cat's cost. Okay, so we need to get both variables onto one side of that. So then we're going to go dogs minus cats is greater than 0. All right, and if you'll recognize this one from last video, all right, we know that we're just looking at the difference between dog and cats. So you should have gotten a mean of negative 20 with a standard deviation of $46.10. Okay, and now calculate your z-score. You should have got 0.4338 as a z-score. NCDF'd it, and you should have gotten a percentage. The probability will be 0.332. Okay, and then it asks us what concerns do you have. All right, you'll notice an example. I didn't say anything about them being independent. So you would just want to make sure that they are independent of each other. Alright, so that's the last example for this video. So tomorrow during class, again, you're going to get another little worksheet to kind of reinforce the ideas. And then I want you to do your Math Excel, do your book work in class, ask each other questions, help each other out. And I will be here the next day. Thank you.